Hi, Singapore. I'm extremely excited to be with you today. My name is Omar. I'm the director of the AI Machine Learning team in Esri, and I'm very happy to spend with you some time today to talk about AI machine learning with ArcGIS. There are going to be two major themes that we're going to cover today. The first one is automation, automation, automation. We are going to show two workflows that show how we are using the deep learning tools in ArcGIS to save a lot of time in problems that we have been spending too much time in dealing with. So I want you to think about the possibilities for automation in your context today. The second theme is going to be about using AI in ArcGIS helps you answer bigger questions and tackle bigger problems. So let's jump directly into it. AI is the big idea of achieving human level intelligence. And machine learning is one field of AI that's about learning from data to derive rules and extract patterns, instead of being explicitly programmed. And deep learning is one specific kind of machine learning. It's using a specific technique called deep neural networks that is becoming recently very good with high dimensional data like images, voice, or text. In ArcGIS, we don't really have a product for AI. It's a capability that spans multiple products. So you can find it today in different products like the ArcGIS API for Python, ArcGIS Notebooks, ArcGIS Pro, Enterprise, Image Server, Image Analyst, and we are adding it to more and more products. And as you know, we have three major capabilities that we have been having for years when it comes to machine learning in ArcGIS. You can use the machine learning tools in Pro, for example, to make predictions or find patterns using the clustering tools. These are machine learning tools. And you can use the tools in imagery to classify imagery, right? You can classify overhead imagery into previous and in-previous services, for example. Now, recently, as you know, we have been adding the deep learning capabilities that can help you extract objects, detect change, or classify land cover from imagery. And in addition to that, we have added the natural language processing capabilities, some NLP capabilities that can help you extract entities out of unstructured text. So I want to start with the imagery AI capabilities that we have. It's not just about training models and using them, it's about an end-to-end life cycle, starting from getting the imagery from multiple sources, whether these are aerial imagery, satellite imagery, or drone imagery, and then processing the imagery and preparing it for deep learning. You can use the different functions and capabilities in Image Analyst and Image Server for that. Next is preparing the data for deep learning. If you want to label some data, we have brought in some new tools for that. Labeling data for deep learning. And then once you do this, you want to export the data and start the step before the training, which is having those image chips, right? And you can do image augmentation to produce a wide variety of imagery so that you can better train your models. And all of these are available in ArcGIS today. After this comes training. So we have brought in a lot of different kinds of neural networks recently to help you train different models based on the need, whether it's instance segmentation or object detection or pixel classification, you name it. And then once you have trained models, you can deploy them to production. You can use them locally with Pro and Image Analyst, or you can upload them to Portal and use them with Image Server to scale the inference to massive areas in less time. And most importantly, after you do this, you can build information products on top of that easily. You can do spatial analysis, you can do spatial machine learning, you can do whatever you need to derive the information product that you want. So this end-to-end cycle is what we're talking about here today. And I want to show you a demo of this. So let's jump directly into it. So I'm going to open Pro on the Woolsey Fire project. This is an area that was subject to massive amount of fires, leading to a lot of structure being damaged. So what we want to do here is we want to do two things. First, detecting the building footprints, because guess what? There might be buildings that are not registered in the database. So we want to find out all of those buildings, and then we want to apply another deep learning model to classify the damage. So let's have a closer look into some areas here. So let's zoom in here, for example. We're going to find a lot of these buildings. So let's say we don't have any building footprints. We need this to train the model. As you know, we need some examples to train the model. So we're going to label some data. And for this, we're going to use some of the new tools, like the label objects for deep learning tool that you can find under imagery. So using this tool, I will start labeling some data. So from the tool, I'm going to select a polygon, add a class. Let's call it buildings, for example. Give it any value. Give it some color here. Let's choose that one. Okay. and start labeling. Let's label that building, for example, right? So I want to have polygon here for this building. So using the label objects for deep learning tool, I'm gonna create a training data set by labeling a lot of polygons for these buildings. And these are going to be some examples for the polygons I've created. Now, once I've done that, I want to start exporting these into chips so that I can start training a building footprint detection model. So how can you do this? We're gonna launch our first tool here, export training data for deep learning. This is a tool that takes two inputs, the raster and the feature class that we've just created. So we are passing the imagery raster here, right, as you see. We're passing the building woolsey, which is the layer that we've just created. And we can define some parameters like the strides, for example, and the tile sizes. And then we click run. Once we click run, this is going to be the output. If we go to the footprints training data, we're going to find two folders, images and labels. The images are the image chips that were exported, and you can see this here. Let me expand the icons. So a lot of image chips, and then the labels that are associated with how these chips are labeled, right? It identifies the kind of labels for each chip that the deep learning model needs so that it makes a training process. You can find this under labels here, right? So once we do this, now we can train a deep learning model. We're gonna launch a second tool. Let's have a look at it here, called Train Deep Learning Model. You can use this tool in Pro 2.5 Plus, so we can find it in 2.5, you can find it in 2.6. And to use it, you need the image analyst extension. And for that, you can use it to train deep learning models. We have different kinds of deep learning models that you can use. Here, we're gonna pass two parameters. First, the training data. So we're pointing it to the folder that we have just created, the footprints training data, right? And second, an output folder for the model. And then you can then select the type of the model that you want to run. Now, given the type of the training data, the tool recognizes that we most probably need to train a pixel classification model. In that case, we're going to select a unit. And that's one aspect about the tool, that it can recognize based on the data what are the appropriate models that you would want to be using. And then you can identify some advanced techniques. Let's say, for example, you have a pre-trained model that you have trained before. You don't need to start from scratch. You can start from here. So if you select the pre-trained model from that folder, you can just build on top of it. Now, once you run that, you're going to have a model for detecting building footprints. And for that, we're going to want to run this model and have it actually process across this imagery to detect the building footprints. So for this, actually, we're going to launch another tool called Classify Pixels using deep learning. So if you launch that tool, you're going to pass the imagery, the output folder, the model definition. The model definition is the EMD file, which is generated from the previous tool. Think of it as a configuration file for the model. And you're going to actually point to that one here. Let's go to the footprints model and select the EMD. And then actually, we're going to just run the model. So it's loading the EMD file right now, and it's going to help us do that. Now, one tip here is that if you want to run across a small to medium area, you can do this locally in Pro if you have a good GPU. If you want to scale this to massive areas, do it in less time. You can do this with Enterprise with image server. If you have multiple image servers, you can configure it to use distributed raster analytics and use deep learning with distributed raster analytics to run the inference at massive scales in less time. So as you can see here, I'm defining some parameters, and I can just click run, and the output of that is going to be this. So let's go to this area. And see the footprint masks. So you see these masks are the ones generated from the deep learning process. Now, as you can see, they look nice, but they are not that uniform. They might need some level of processing. And this is where we use some post-processing tools, like the regularized building footprints, to make the results even better. So the output from that is going to be like this. So you see this, how is it looking way much better than the other one? And for that, I'm saying that doing AI in ArcGIS helps you answer bigger questions. So if you're just using a model outside, you're going to generate these masks. But if you want to take it to the next level, make the results better, you can use some of the post-processing tools like we have just shown to generate this. So that was the first part. The second part is we want to detect the damaged buildings. So we're going to need to generate some training data for that. And we have in fact done this. We have labeled some of these polygons, whether they are damaged or not, by adding an attribute to the table, to the feature table, right? So let's have a look at these. إيه اللي حصل؟ So these are some of the example labels that we have created. And now we want to train another deep learning model to detect the damage. In that case, we don't want to detect the building footprint. We just need to classify the object, whether it's damaged or not. So let's go to geoprocessing and go to export training data for deep learning for the second time. And now we're going to pass the damage training samples that you can see here as the labeled examples along with the raster. And it's going to generate an output folder like this. So we have another folder here. It's called the damage training data. Same thing, images and labels. Images includes the image chips. Labels include the label for each of these chips. And then you can use that to train a model. So we're going to go to geoprocessing and choose train a deep learning model. In that case, we're going to pass the damage training data, and we're going to specify an output folder to host the model. We can define some parameters. We can, again, as I mentioned, use some pre-trained models. And when we run this model, this is going to be the result. So we have run the model across this area to find out all of the damaged buildings. And as you can see the results here, let's zoom in to explore them. You're going to notice that the model is accurately catching up on those damaged buildings. You can clearly see the level of damage here at these buildings, while the others that are marked in green looks good. And we have done that across all of this area, as we have mentioned. One thing to mention here is that we have run this locally. It took almost 4.5 hours. We have run it on 4 image servers using good GPUs. It took just 20 minutes. So that's the kind of scale you can do with image server. Now, with that said, I want to shift gears to another demo. But before this, I want to reflect on something. Now, this kind of work could be used with a lot of other features. You can do it, actually, you can use this methodology to extract the building footprints from massive areas. So see, this is the kind of result of extracting the building footprints from Redlands, California. We have done it across big areas. Same thing with road segments, so extracting roads. I mean, this looks as a good area, but we have done that in the desert as well, in some areas that you can barely see the road with your eye, and a lot of other examples. One of the major success stories that we have is PASI. PASI is the public authority for civil information in Kuwait. And previously, they had about 4 or 5 people working for like 5 hours a day for 1 year to digitize the whole country, extracting the building footprints and the road segments. Using deep learning with ArcGIS, now they are doing the whole country in almost 30 minutes. Can you imagine that? From almost 5-man years to 30 minutes, that's the power that deep learning can bring to the table. And that's the power of automation that I want you to think about for the different workflows that you have. Now, you can go and access this use case online. If you go to this URL, we have written an entire blog post about it. And these are some other examples that we have been doing using this technology. Detecting land cover, pipeline encroachment, road detection, oil pads, road cracks, cars, palm trees, swimming pools, anything that a human being can detect under 1 or 2 seconds. In general, we can train AI models to do it. So let's shift gears to another example, LiDAR point cloud feature extraction. Now, what we want to do here is this. So we want to automatically generate this beautiful 3D scene that you can see in a totally automated fashion using deep learning and powerful GP tools in ArcGIS. So we are starting with a big set of LiDAR point cloud. This is the raw data as you can see it. The legend reflects the elevation. So we have a huge amount of those point clouds, and we want to automate the whole process instead of manually trying to detect where are the buildings, where are the trees, where are the roads, etc., etc. So we're going to use different things here. One of the things that we're going to use, and obviously, as you can imagine, this process is very time consuming due to the nature of point cloud being totally unstructured. So we're going to use something called point CNN. Point CNN is a deep learning technique that we have brought in the ArcGIS API for Python that can help you train deep learning models to detect and classify features from LiDAR point cloud. As you can see, these are some examples, and this article actually on the developers.arcgis.com explains how point CNN works. So let's get right into it. So we're going to use ArcGIS notebooks on ArcGIS Online, which, as you know, shipped recently, and I really encourage you to try it out. And one version of it comes with GPUs that can help you train these deep learning models. So we're going to start installing some prerequisites, some of the libraries and the frameworks that we need, like PyTorch here. And let me walk you quickly through the notebook. So we are using ArcGIS.learn, which, as you know, is part of the Python API, including a lot of capabilities when it comes to deep learning. So ArcGIS.learn can help you prepare data for deep learning, do image augmentation, train deep learning models, use deep learning models, and deploy deep learning models into production. So first thing, we're trying to export the training data. So we got some training data from the Netherlands and UK that we're exporting here using the export functionality. And then we're doing some data prep and showing some examples for this data. As you can see here, this is a quick example where you can see the two classes, 0 and 1. First of all, we're going to train one model for detecting buildings, and then we're going to train another model for detecting trees. So we're going to start with the building model, where we launch point CNN, and as you can see, it's extremely easy to launch it as you see here. So we're getting point CNN, and we're seeing that it has two classes, the label data, 0 and 1, buildings and non-buildings. We're using the learning rate finder, which can help you find the optimal learning rate, a good starting point for the learning rate. And then actually pc.fit is where we train the actual model. As you can see, it's a couple of lines of code to train a deep learning model. And once you do this, you can start actually do the post-processing. So the results from the deep learning are good, but we want to use some post-processing tools in ArcGIS to help make them better. So these are examples for the post-processing techniques we're using with the buildings. So we are converting the last to raster, reclassify, raster to polygons, make feature layer. At some point, we're using the regularized building footprints. The bottom line is we're trying to take the output from the deep learning to detect the building footprint. And then from there, we're doing a couple of things, right? We're trying to derive the attributes. That's this part specifically here, deriving some attributes from the LiDAR, like the height of the roof and the kind of the building. So we're populating the attribute table with that. And then we're using City Engine to convert these results into beautiful 3D shapes. So we're using City Engine's rule package, and specifically we're calling the features from City Engine Rules GP tool. And this is going to help us generate realistic 3D buildings. And then using City Engine, again, we're overlaying the texture. So that's the part for training the building model. Now we have another model for the trees. We're doing pretty much the same thing. So exporting the training data. We have a bigger model that is detecting multiple classes. We're particularly interested about the trees. We're calling the point CNN. We're doing the inference. And then we're doing a similar post-processing here. Now I want to show you some examples for the post-processing that we're doing for the trees. And actually we can better see it on this beautiful map. So this is the output here from the deep learning, right? You can see here that this is detecting the different classes, as we can see. The buildings are classified as red, the trees are classified as green, and then we're doing some of the post-processing. In case of the trees, for example, we're finding out the tree diameter. We're deriving the tree footprint. So that's what you're seeing here, these circles, right? And then we're using density-based clustering to find out these clusters of points to understand this exact area for the tree, right? So we're populating the attribute table with different things. First, the footprint of the tree, the height of the tree, and then deriving some other attributes using CD Engine as well, like, for example, the canopy, the tree canopy height, maximum height, the minimum height, the total surface area, the 3D surface area, and then using some other post-processing tools. In CD Engine, for example, we've been using the vegetation CGA assets to find out the best guess for the tree spaces for these trees. And then that's the final output that you can see here. After finding out these tree examples, we are choosing some of those examples to have here, and then overlaying the texture on the buildings, as you can see. That's a closer look that you can see. And imagine how beautiful this is. How beautiful it is to take raw point cloud and leverage the power of deep learning with ArcGIS to arrive to results like these, saving a lot of times. And this is not just the only example. We have worked on a lot of other examples. This is one of the examples we've been doing with a utility customer, where we took 10 billion point cloud and we helped them save 50,000 hours by automating the detection of utility poles and lines, as you can see here. And we also included vegetation at some point on other classes. We have been doing some work with traffic light detection, detecting traffic lights and other street assets. We have been doing other works with rail, detecting rail assets like signals, mileposts, crossings, and switches. All of these are just few examples for the power of automation that could be brought by ArcGIS AI capabilities. Now, I really encourage you to leverage these capabilities that you have seen today to bring automation to your workflows and save time, cost, and effort. Thank you.